Hey guys, Mr. B here, and in this video we're going to be going over the notes in chapter 3.3 on dimensional analysis and conversions. Alright, so this section is a little bit math heavy. It involves some fraction math, so if you are not good at fraction math, I'm going to try to teach it to you as best as I can. And if you're already good at it, then this should be no problem for you, okay? So in this section we're going to learn how to convert between different units, mainly in the metric system, but just in general, right? So what happens when we have a measurement and we multiply it by a conversion factor? So to remind ourselves, a conversion factor is a ratio of equivalent measurements. So the word ratio means a fraction, and equivalent measurements means that we have two numbers that are equal in size. They're just different units. So for example, a conversion factor could be 100 centimeters over 1 meter, or 1 meter over 100 centimeters. These are two different numbers that are equal in length. Okay, so this would allow us to convert between meters and centimeters. So we can write it as a fraction with the 1 meter on top and the 100 centimeters on the bottom. We could also flip it around so that we'd have 100 centimeters on top and 1 meter on bottom. Either way, yeah. So when we have a measurement and we multiply it by a conversion factor, the numerical value is generally going to change, but the actual quantity itself remains the same. So what this is saying is that when we do math and we convert units, the number that we end with is going to be a different number than what we started with, but the overall value of that number in terms of how much it's representing doesn't change. Okay, it stays the same size. So, for example, if we had a number in nanometers, which is a billionth of a meter, or 1 meter, the number may get bigger or smaller if we convert from meters to nanometers, but the total size of that length is going to be the same regardless what unit we're in. So, all right, so let's get into the whole converting thing. So there's a term here we're going to talk about called dimensional analysis. It's basically a very fancy way of saying converting, okay? And it's how we convert units. So what is dimensional analysis and how does it work? Dimensional analysis is a way that we analyze and solve problems using the units or dimensions of our measurements. Okay, it's just an alternative approach to problem solving, and it's a really easy way to learn how to convert units so that you just don't get confused. As well as once you understand how to do it, you pretty much can convert anything. It doesn't matter what your numbers are. So let's take a look at an example here. Okay, so it says how many seconds are in a workday that lasts exactly 8 hours. So we're going to walk through the steps here of what the problem is saying. Okay, so 1, the time that we worked we know is 8 hours. We know that in 1 hour there are 60 minutes, and in 1 minute there are 60 seconds. So the question is asking how many seconds are there in 8 hours. And these are the two conversion factors that we need to know for this problem. 1 hour is equal to 60 minutes. 1 minute is 60 seconds. So the first conversion factor we're going to write so that the unit of hours is in the denominator on the bottom. And the second conversion factor is going to be written with the unit of minutes in the denominator. Okay, so basically what this is going to look like is this. We're going to be starting with 8 hours, our known value. We're going to multiply it by 60 minutes over 1 hour. And we're doing this because when we write our conversion factors this way, whatever unit is on the bottom of our fraction is going to cancel out with the unit that we're starting with. So we want to cancel out the units of hours to get into minutes. And then once we get into minutes, we're going to multiply by 60 seconds over 1 minute so that, again, the units that we have now, which is 60 minutes and 1 minute on the bottom, those will cancel out. And the unit then that we're left with that we have not canceled is seconds, which is the unit that the answer is looking for, right? Is how many seconds are there. So we take 8 hours times 60 minutes over 1 hour, or basically just times 60 equals 28,800 seconds. And if you want to, we can put it into scientific notation as 2.8800 times 10 to the 4th seconds. Okay, so the units that we're ending with are in seconds. And since the second is a smaller unit of time, the answer should be larger than 8 hours, right? So our final answer was 28,800. That makes sense, seeing as seconds are a smaller unit, you're going to have more seconds in 8 hours than you would just have 8. So, okay. All right, here's another example. The directions for an experiment ask each student to measure 1.84 grams of copper wire. The only copper wire available is a spool with a mass of 50 grams. How many students can do the experiment before the copper runs out? All right, so let's take a look at this one, and let's actually do this one out ourselves. So here's what we know. Here's our known information, okay? So we know there is 1.84 grams of copper, and we know that, we know that for every one student, they're going to use 1.84 grams of copper. So 1.84 grams of copper is equal to 1 student. Okay, that's our conversion factor. Each student needs to measure 1.84 grams, and we know that we're going to be starting with 50.0 grams of copper. So, as for the math, we're going to start with 50 grams of copper, okay? And if you want to, let's just imagine that this is a fraction. So let's imagine it's 50.1 grams of copper over 1, okay? And we're going to multiply this by our conversion factor, which is going to be 1.84 grams of copper per 1 student. And all we're going to do is make sure that we put the grams of copper on the bottom of our fraction, so it cancels out with the grams of copper on the top of our fraction to begin with. So we're going to have it as 1 student, like this, and 1.84 grams of copper on the bottom, so that grams of copper here, and let's go format, text, strike through. Grams of copper there will cancel out with grams of copper here. Okay, so grams of copper, those two units will cancel out. And once those units cancel out, our final answer will be in some number of students. Okay, and all we have to do is do the math. So we are going to take 50.0, and then we're going to divide that by 1.84. Okay, now we could also think of this as 50.0 over 1 times 1 over 1.84. But if you multiply by 1 over 1.84, it's the same thing as just dividing by 1.84. Okay, so if we do this in a calculator, we will get 27.173 whatever students. But seeing as students are individual people, we probably want to round this to a whole number. So we're going to round this to 27 students. So 27 students could do this experiment before the copper runs out. Okay. So again, what we're doing is we're taking the units of 50 grams and we're multiplying by our conversion factor, and we want to have this opposite thing going on with our fractions and our units so that they cancel. Okay. And if we check the work here shown in the problem, we'll see that they get the exact same answer we do. They even have the same math. 50 grams of copper times 1 student over 1.84. They get 27.174, and they round it to whole numbers. So, okay. So, converting between units, what types of problems are easily solved by using dimensional analysis? So problems usually where we have one unit and we're converting to another unit is where we want to use dimensional analysis. Okay. Now, when you have a single conversion problem where you're just converting from one unit to another, you can use dimensional analysis. You know, you might be able to think about doing it in your head, no problem. It's really when you have multiple conversions from one unit to another to another to another where dimensional analysis really, really shines. So let's take a look at another example here. So it says express 750 dg in grams. So just to remind ourselves what dg is deci. Okay, so dg is decigrams. So basically this is saying express 750 decigrams in grams. So the conversion between, so again, let's go known values. So things that we know. So what we know is we have 750 decigrams. Make sure our font is the right size. There we go. So we have 750 decigrams. And we need to know what the conversion is between decigrams and regular grams. And this is just knowing what deci means as a metric prefix. So deci means 10 times smaller. There are 10 decigrams in 1 gram. Okay, so 10 decigrams equal to 1 gram. So from here, we're basically just going to, I'm just going to delete this picture so we can have some more space here. We are going to take 750 decigrams. And again, if you want to think about it as over 1, you can. And we're going to multiply that by our conversion factor. And since we're starting with decigrams, we want to have the 10 decigrams on the bottom. So it's going to have 1 gram on the top and 10 decigrams on the bottom. Okay, so it's going to look like this. So decigrams here will cancel out with decigrams here. And our final answer is going to be in the units of grams. So we're going to take 750 decigrams and divide that by 10 decigrams. And we'll get our answer. So 750 divided by 10 is 75. So our final answer should be 75 grams. And we'll put this in black and underline it. Okay? And there we go. That's our problem. That's simple. If we look at the math again that they show, again, they show known values are 750 decigrams. 1 gram is 10 decigrams. And they do the same math we do. They get 75, just like we did. So, all right. Now, again, really where dimensional analysis shines is with multi-step conversion problems. So when we're converting from one unit or more than one unit to another, this is really where things are nice. Okay, so here's an example. What is 0.073 centimeters in micrometers? Okay, so this is going to be a two-step problem, and let's explain why this is a two-step problem. So we're trying to convert from centimeters to micrometers. Now, we could do this in one step if you know how many micrometers are in a centimeter. You might know that, you might not. You could Google it for sure. But let's just think about it this way. How many centimeters are in a meter, right? What does centi mean? Centi means 100 times smaller. So we know that there are 100 centimeters in 1 meter. Okay. And then we can think, well, what is micrometer? How many micrometers are in a meter? Well, micro means 1,000,000 times smaller. So there are 1,000,000, and we'll do the special character for micro. So let's go to insert special character. Let's type in mu, and there we go. So this weird looking M thing. So there are 1,000,000 micrometers in 1 meter. Okay, so those are the two conversion factors that we know. And we also know that we're starting with 0.073 centimeters. So what we're going to do is we're going to do this in 2 steps. We're going to start with 0.073 centimeters. And again, if you want to think about it as over 1, you can. And we're going to first convert this into regular meters. Then we'll convert from regular meters to micrometers. So we are going to go multiply this by 1 meter over 100 centimeters. Okay, that's our first conversion factor. So centimeters will cancel with centimeters here, which will cancel. And this conversion factor here is what we have written right here. Okay, this is the 1 meter over 100 centimeters. That's this first conversion factor. Then the next part we're going to do is, once we've done that, we now are in the units of meters. So the next conversion factor is to go from meters to micrometers, and that's by using this conversion factor. So now that we have 1 meter here, we want to have the 1,000,000. Oh gosh, what am I doing here? Hitting buttons, that's what's going on. Sorry about that. Okay, we're going to have 1,000,000 micrometers. So again, let's use our special character mu. Micrometers, and then over 1 meter. Let's not, I guess we're going to strike that out anyway, but okay. So 1,000,000 micrometers over 1 meter, and now we have 1 meter on the top and 1 meter on the bottom. So that unit of meter is going to cancel. So meters will cancel out there, and meters will cancel out there. And now the units we have left are micrometers, which is exactly what the problem wants us to get into, is final answer micrometers. Okay? So if we do this math out, on a calculator, see what we're going to get. So let's see. We take 0.073, divide by 100, times by 1 million, and I get 730, I'm just going to copy paste this, micrometers. Okay, 730 micrometers as our final answer. So we can see here, this is what we call dimensional analysis, where we take our units that we're starting with and we use conversion factors in the right way so that the unit we're starting with here cancels out with the unit on the bottom of the conversion factor so that they're opposites, they cancel, and we just kind of keep on canceling our units until we get into the units that we want as our final answer. And then we just do the math out. And we can check our work here. So like, again, they have the same stuff here. They even show the same steps that we did. They put things in scientific notation, which is fine. So 7.3 times 10 to the second, that's 730. It's the same answer that we have. They just did it in scientific notation. So, all right. And then the last part here is converting complex units. So a lot of common measurements are expressed as a ratio of two units. One prime example of this is density. Density is a number that is usually going to have two units on it, like grams per milliliter. So if you use dimensional analysis, you can convert complex units just like you would be using converting single units, and you can do that in multiple steps to get your answer. So here is an example of that. So it says the mass per unit volume of a substance is a property called density. The density of manganese, which is a metallic element, is 7.21 grams per cubic centimeter. What is the density of manganese expressed in the units of kilograms per cubic meter? Okay. So let's do this last problem here, and then this will be it for this section of notes. So again, let's do what we know already. So what are our known things? So we know the density, which is 7.21 grams per cubic centimeter. Okay. And we're going to need to convert grams to kilograms and cubic centimeters to cubic meters. So let's think about what is the conversion between grams and kilograms. Well, kilo means 1,000 times bigger. So a kilogram is 1,000 times bigger than a gram. So there are 1,000 grams in 1 kilogram. And we also need to convert cubic meters, or cubic centimeters to cubic meters. So I don't know how many cubic centimeters are in a cubic meter, but I do know there are 100 centimeters in 1 meter, right? There are 100 centimeters in 1 meter. And if I want to have it as cubic centimeters and cubic meters, I'm just going to cube both of them. So if we take 100 cubed, so basically 100 times 100 times 100, okay, that will get us cubic centimeters. So if we cube that, and if we do the same thing to 1 and we cube that as well, so 1 times 1 times 1, this will give us cubic centimeters and cubic meters. So on my calculator, if I take 100 times 100 times 100, this gives me 1,000,000. So 1,000,000 cubic centimeters, and then 1 times 1 times 1 is just 1, and that's 1 cubic meter. So this is our regular conversion between centimeters and meters, but if we cube them, we can now get a conversion factor between cubic centimeters and cubic meters. And so at this point, we have all the information that we need to solve this problem. We just got to set up the math. So what we're going to do is we're going to start by taking 7.21 grams over 1 cubic centimeter. Okay, this is our density. So this density that we wrote here, I've just written it now as a fraction. This is what it looks like. Okay, 7.21 grams over 1 cubic centimeter. And we're going to first cancel out grams to kilograms. So the first conversion factor we'll use will be this one, this 1,000 grams and 1 kilogram. Since we're starting with grams here on the top, we want to have the 1 kilogram on the top of our fraction. And we want to have the 1,000 grams on the bottom of our fraction, so that grams are on the bottom there and grams are on the top here, so that they're opposites and they cancel out with each other. So this will convert our grams into kilograms, which is what our final answer wants. Then all we have to do is convert our cubic centimeters into cubic meters. So the next part now is we're going to do that. We're going to do that by using this conversion factor right here. So since we have 1 cubic centimeter on the bottom, that means that on the top of our fraction, we want to have the 1,000,000 cubic centimeters. Okay. because we want cubic centimeters here to be opposite with these cubic centimeters. Okay, that's how they cancel. If you have the same unit on the top and bottom of a fraction, they will cancel out with each other. So we're going to do that, and then we're going to have on the bottom the 1 cubic meter. Okay, so that's this part of the conversion factor. So now we'll have cubic centimeters here, which will cancel with the cubic centimeters there. And when we're all said and done, the only units that we have not canceled out are kilograms and cubic meters, okay, which is exactly what our answer wants. So now we just have to do the math. So if we take our calculator and we go 7.21 divided by 1,000 times 1,000,000 equals, we get a final answer of 7,210 kilograms per cubic meter. Okay, and that is our final answer with the units that they are looking for, which is again kilograms per cubic meter. Okay, so again, we can see our units canceling out, and this is why it's so important to write your units on your measurements. All right, so that is it for this section of notes. The rest are just some practice problems, and of course, there's a video of me going over those practice problems as well. So I am Mr. B. If you have any other questions, feel free to reach out, but otherwise, I will see you in the next video. Bye.